Trey.
And I'm TJ.
Tonight, we're gonna look at Mars.
Man, it's bright.
Yeah, it's because this is the closest Mars has been in like 60,000 years. Mars is really orange.
Or just kind of reddish.
Yeah, and you can see the two ice caps really easy. Mars is my favorite planet because it's got mountains and craters and stuff just like Earth does, but it's more extreme.
I think it'd be cool to be the first person on Mars because you'd be stepping where no man had ever stepped before. You'd find different and new minerals, maybe even life forms. It'd be awesome.
One small step for man.
We keep up with images that NASA sends back from Mars.
There are many pictures taken by the rover on the planet's surface and orbiting satellites like NASA's Mars Odyssey.
We found cool images from the Themis project taken with a camera that sees infrared light. But we wondered what the different gray areas meant. We found out that this infrared, or IR camera, shows how hot and cold things are on Mars. And they are using IR images to look for water, even though there's no open water on Mars. Instead, they're looking for underground hot springs that would show up as hot spots on the surface.
That's a wee bit strange, isn't
I
it?
think it's so cool that there might be liquid water underground on Mars.
Yeah, because where there's water, there could be life. We wanted to see for ourselves how an IR camera could help you find water.
So we contacted the scientists at Arizona State University who were controlling the Themis camera.
And we borrowed an IR camera ourselves so that we could figure out just how a satellite orbiting Mars could find underground water on the planet's surface.
Before we can start looking for water, we need to understand how an IR camera works.
An IR camera records different temperatures using different shades of gray and sometimes different colors.
In the color camera that we're using, we get to assign colors to a temperature range. Things that are warmer look redder, and things that are colder look more blue. So a rock that has been heated by the sun all day looks red.
And a pond filled with cold water looks blue.
Tell it like it is.
We set out toward Hot Springs country with an IR camera to see how the Mars satellite team might find underground water.
Thanks for the ride, sir.
Thanks, Dad.
Bye.
Here we are on a potentially hostile planet in the wilderness. Space explorers willing to take any risk
For a nice, hot, soothing bath.
That's crazy, man.
We know there are hot springs around here. We just don't know exactly where.
To see how different materials heat up during the day, we'll take a reading of this spot while it's still in the shade.
And when the sun warms things up, we'll take another reading to compare the results.
All right, TJ, get a reading of this tree right here.
72 degrees,
What about this group of rocks right here?
75, 76,
Try this big old sandy wall right here.
82, 83 degrees,
Try the floor.
73 degrees.
When we finished collecting our data, we set off again in search of hot springs.
Oh, look at that water over there.
Cool. It looks nasty, though. Here, get a reading of that rock.
The really hot spots where it's white are about 116 degrees. The shadowy part, they're about
cow.
82 degrees.
We weren't finding any hot springs, so we circled back to the gully to take new readings in the sun.
Oh, it's really hot down here. So the tree went from 73 to 103, which is 30 degrees. The wall went from 82 to 96. The group of rocks over here went from 75 to 104.
140.
And then the floor went from 73 to 130.
Wow.
The group of rocks
still.
got the hottest, probably.
And what's the coolest?
the coolest is the sand wall.
So the sandy wall only heated up by 14 degrees, but the rocks on the ground heated up by 65 degrees.
So basically, different surfaces absorb heat at different rates.
So that must be how the IR camera looking at Mars works.
Yeah, they tell different substances apart by how much heat they give off or absorb.
Everything looks the same to us, but it sure doesn't look the same to the IR camera.
Let's keep looking for the hot springs.
We were hoping the IR camera would help us find underground water by showing us unexplained temperature changes on the surface. but everything got so hot that we couldn't tell hot springs from hot rocks.
We've been at this for hours. I hope we find something soon. TJ, get over here. Look, there's a pool of water right there. Oh, right there? Yeah. I think we found it. What?
So we'll try to find signs of underground water again. But next time, we'll start out before the sun comes up.
Hey, Trey. What? You know the real reason why they're searching for hot springs on Mars? It's even astronauts need to relax. Check out Mars.
In a night sky near you.